Hello designers and welcome back to the Fusion 360 Explained by Akir course. In today's video, we will be taking a look at joints, how to use them, and their functionalities. So, what are joints? Joints are basically the combination of two different components put on together under certain parameters. Now, there are a lot of types of them, but luckily for you, I have created a file with one example for each one of them. So let's start seeing them one by one. Now the first and most common joint is the rigid joint. This allows two components to be put together in the same place. However, before we start any joint, there's one thing we need to do, and that is ground the component we know will stay in the same place after the joint. So in this case is this one, rigid with number 1. So I will go to the component tab, right click on it and click on ground. Now this allows this component to stay the same after the joint, while this one is the one that will actually move to be put together with this one. Perfect! Now we can start making the joint. To do this, go to the Assemble tab and click on the Joint option. Now it will ask us for the two components that will be joined. Now there's a thing we need to understand, and that is that the program on its own does not know how to put these two components together. So we have to show them which points of both components will be together. To do this, click on any point you want on the component. Now in this case I want to choose this one, and then click on in what point will this point be placed in this component. In this case, this one right here. Now as you guys can see, the joint has been done. We can change the type of joint by going to motion and changing the type over here. However, in this case we want a rigid joint. Finally, click on OK to finish the joint, and now our two components had been assembled. What does this mean? That now both of them will never separate each other. See? It doesn't matter what I do, they will not move. Why? Because the joint that we done is a rigid joint and this component has been grounded. Perfect. Now let's continue with the Revolute joint. Okay guys, sorry for the cut right there. Now going back to the topic, Revolute joints. What do? They basically allow two components to be put together while one is still able to spin on itself. Now in this case, this is the component that will spin and this one will stay in the same place. So first up, I will ground this component. So I'll go to the component tab, right click on it and click on ground. Now we can start making the joint. I'll go to Assemble and click on the Joint option. Then I will select this point on this component and this point on the other. Perfect. As you guys can see, now the two components are put together. However, if we go to motion, we see that the type is rigid. We will change that to Revolute. Now a little animation is being done. Did you realize something is wrong with it? Let me put it again. As you guys may have realized, the component, the blue component, is going through the orange component. Now in real life, this isn't possible. So how can we change this? Now what we do in these cases is that we create what are called joint motion limits. To create joint motion limits, first we need to allow them. To do this, click on the square right here. Now it will ask us for a minimum degrees, a maximum degrees, and the rest position. So in this case, the minimum degrees will be minus 90 degrees. Why? Because as you guys can see, this is the minimum position. Then the maximum degree will be 90 degrees. because as you guys can see, this is when it starts touching the other component. Now we can click here on preview limits to see how the joint motion limits are being applied. If they seem right, click on OK and the joint will be finished. Now as you guys can see, a folder right here with all the joints had been created. If we wanted to change any joint we want to, we would go here, right click on it and click on Edit Joint. Now, thanks to the Revolute joint, we can grab this component and spin it, but it can only reach here thanks to the joint limits. Pretty cool, right? Now, let's move up to the next joint. Now, this next joint is called the Cylindre Joint. It basically allows one component to slide through another one while the other one stays in the same place. Now, in this case, I have already grounded the components, and the same happens with the next examples. This way we won't lose time doing that. So I start creating the joint. I'll go to assemble and click on joint. Now in this case, the points I will choose are this one, it's hard to get, that one, and then that one. Perfect. Then I'll go to motion and change the motion from Revolute to slider. Now as you guys can see, the animation being done is how this component is sliding through this other one. However, if we put it again, as you guys can see, it goes through it. So what do we need to do? Again, joint motion limits. So first I will allow them and then I will start setting them. So the maximum in this case will be, let's see, 100, no, 200, a bit more, 210, oh sorry, there we go. Now as you guys can see, it's not an easy process and it's basically trial and error until you get that measurement right. Now if we click on preview limits, as you guys can see, the joint motion limits are placed correctly. Now I'll click on OK to finish this, and as you guys can see, I can slide this component, but it stops right here and right there. Perfect. Next up we have the cylindrical joint. Now the cylindrical joint is basically a combination between the Revolute joint and the Cylindre joint, where a component can slide while it spins around on itself. Now again, I already grounded this component, so I can start with the assemble. I'll go to the assemble tab and click on joint. Then the points I will select are this one and this one. Now as you guys can see by the animation, you may have realized that again we need to put joint motion limits. However, this time it's a bit different. Why? Because we have two different motions, the spin motions and the slide motion. So we need to set up the motion limits for both of them. Now for the slide, I'll put a minimum of 0 and a maximum of maybe minus something. No, sorry, I'll put a minimum of minus 20, a bit more, minus 30, more, 40, 60, until we get the thread completely through. 70, one more, 80, perfect. And a maximum of 20 maybe. Yeah, that seems correct. Then I won't put any limits on the spin motion because really we don't need one. So I'll click on OK, and as you guys can see, this thread can slide and turn at the same time. This is really useful when trying to show things like this one, where there's threads that need to spin while entering. Perfect. Now next up we have the pin slot joint. Now basically the pin slots allow a component to slide while turning. Now you may be thinking, what's the difference between the pin slot and the cylindrical one? The difference is that in the cylindrical one, the component slides and turns on the same axis, but in the pin slot, it does it on different axes, meaning it slides in one axis and it turns on another one. Let's see it. I already quantified the component, so I'll go to Assemble, click on Joint, and then the points I will choose are this one and this one. Then I'll check that the motion is correct, and yes it is. And now I'll move on to the joint motion limits. Now for the rotate motion, I won't put any limits as I want it to go and do a full turn. But for the slide, I will put some limits. First, minimum of 0 millimeters and the maximum of, again, trial and error, 100, no, sorry, minus 100, more, minus 300, more, minus 500, there we go. Now if we click on preview limits, oops, something gone wrong. I know what gone wrong. Let me correct it really quick. There we go, now it's correct. So I'll click on OK and the joint will be done. Now as you guys can see, it is sliding in this axis, meaning the red one, while turning on the green one. See? However, in the cylindrical one, it is turning and sliding in the same one, the blue one. Perfect. Now let's move on to the planar joint. Now the planar joint is a very strange kind of joint, so it's easier for me to show how it works before I explain it. So I'll go to assemble joint, and I will choose this point and this point. Then I change the motion from pin slot to planar. Now as you guys can see, basically the movement that it does is that it rotates, it does one slide on one axis and another slide on another axis. I won't put any limits so that you guys can see it clearly. See, it goes this way, and it also turns. See? Perfect. Next up we have the ball joint. This is useful for a specific kind of joint. Let me move this component first. Now basically what it does is that it allows freedom of movement within certain angles. So I'll go to Assemble, click on Joint, and the points I will choose are this one right here, and then this one right here. Then I change the motion from planar, that is the one we just did, to ball. Now as you guys can see, it basically rotates in any angle possible. Now I'll put some joint motion limits. The minimum and maximum for this angle will be, let's see, 30 degrees, no, a bit more, 30, no, even more, 50, no, 60, okay, there we go. Now as you guys can see, this is touching the other component, so that is where it will stop. So the maximum will be minus 60 and the maximum will be 60 degrees. Perfect. Then for the other rotation, similar values will be put, minus 60 and a maximum of 60. So, no, 660. So let's see. Yeah, that's incorrect. And then for the other rotation, again, minus 60 and maximum 60. Now I repeat, this is only for my example. In your designs, it may change. Now if we click on OK, we can see that this ball stops right there, and it turns and rotates anywhere it wants to. And well, designers, that's all for today. If you enjoy, please remember to like and subscribe, and if you have any questions, don't hesitate to leave a comment down below. I know the joint topic isn't a simple one, so I will try to answer you as quick as possible. Anyways, goodbye designers!